We've taken a deep dive into how I works, how to simplify negative radicals to get I, and powers of I. But what we need to still look at is how we can do algebra with the imaginary number I. If we're adding and subtracting imaginary numbers, we're just going to combine like terms like we always have. In other words, if I have something like 5 minus 3i, and I want to add to it 6 plus I, all I have to do is combine the like terms of 5 and 6 to get 11, and negative 3i plus I to get negative 2i. And then I'm done. That's all we need to do to add imaginary numbers. Let's be a little careful, though, when we subtract. If I have negative 5 minus 2i minus 3 minus 6i, if I'm subtracting, that subtraction needs to first distribute through the parentheses. So we have negative 5 minus 2i minus 3 plus 6i. And that sign at the end on the 6i is the most commonly missed piece. Don't forget to distribute that negative through the entire parentheses. Now we can combine like terms. Negative 5 minus 3 is negative 8. Negative 2i plus 6i is plus 4i. And we're done. Now, when we get to multiplying complex numbers, there's a little more to it because we have to keep track of the fact that I squared is equal to negative 1 and how that's going to change our simplification step. So if I have negative 3i times 6i, if I'm treating that just like a variable, that's going to give me negative 18i squared. But remember that I squared is negative 1. So we really have negative 18 times negative 1, which makes it a positive 18. Other than watching for I squared to be negative 1, though, multiplication works like multiplication has throughout your algebra experience. If I have 2i times 5 minus 2i, I know I can distribute through parentheses to get 10i minus 4i squared. But again, that I squared is negative 1. And negative 4 times negative 1 gives us a positive 4. And so we really have 10i plus 4. Let's scroll to get us room for some more examples. Let's try multiplying 4 minus 3i times 2 minus 5i. Well, we know we can distribute the 4 through. 4 times 2 is 8. 4 times negative 5i is negative 20i. Negative 3i times 2 is negative 6i. And negative 3i times negative 5i is positive 15i squared. But again, I squared is negative 1. So we really have 8 minus 20i minus 6i plus 15 times negative 1, which makes it negative 15. Now we can combine like terms. 8 minus 15 is negative 7. And negative 20 minus 6 gives us negative 26 i's. Let's do one last example to wrap up this section. Let's do 3 plus 2i and square it. Now, with the plus in there, we can't square the individual pieces. That only works with factors that are multiplied, not terms that are added. Squaring means I'm really taking 3 plus 2i and multiplying it by 3 plus 2i. So I'm going to do much like I did in the previous example, where we do 3 times 3 to get 9, 3 times 2i to get plus 6i, 2i times 3 to get plus 6i, and 2i times 2i to get plus 4i squared. Again, when we see that I squared, we know that's negative 1. So I can rewrite this as 9 plus 6i plus 6i plus 4 times negative 1, which is negative 4. Then I'm just combining like terms. 9 minus 4 is 5, and 6 plus 6 gives us 12 i's, and we've got our solution. Take a look at the homework assignment. Practice some of these. Get really comfortable with working with I, the square root of negative 1, and let your instructor know if you have any questions.